Hello, I'm Dr. Martin Bergman from Ridley Park, Pennsylvania, and I'm here at the RWCS conference in Maui, Hawaii. Recently, I gave a talk on big data, artificial intelligence, and blockchain computing. Whether you realize it or not, we are in the age of big data, and big data simply means large sums of information that we're getting from multiple sources. It can be from data banks, it can be from your EMR, which are probably one of the bigger sources these days. It can be from Google, it can be from any of the wearable devices that are out there. They're just multiple sources. The problem with big data is, frankly, its bigness. It's just the huge volumes of data that are very difficult to handle. So conventional computing standards don't really work. Instead, we have to use other means of doing it, and the most common is what's called artificial intelligence. Artificial intelligence is simply a way of handling this data using algorithms where we have computers and we teach the computers different ways of evaluating the material, sorting material out, and then coming to conclusions based on the sorting. The problem with the sorting is the algorithms require humans, and the humans have foibles. We have our biases, we have our problems, and sometimes that comes into the data. But it gives us an ability to get huge information and potentially get the questions that were unable to be solved previously with just clinical trials or with observational studies. There are two types of big data, or I should say artificial intelligence ways of looking at things. One is something called unsupervised. Unsupervised, simply you say, computer, look at all the data and give me as much and see what you can find. See what correlates, what travels together, what doesn't travel together. Another source, which is probably more commonly used with the questions we want, is something called supervised, which is, let's say you want to answer a question. What patient will respond to a TNF or won't respond to a TNF? Or what patient will have a bad outcome or a good outcome? So what you do is you start with that, you use a training group, and you have the computer find what works or doesn't work with that patient and that group, and then sort it out, go through multiple iterations, keep on going back, and over time the computer is able to sort out what works or doesn't work, or may not have sufficient information. This is becoming very interesting and becoming a very huge source of information, and will answer questions down the line. But the problem with big data and large sums of data is your data has the ability to be corrupted. There are many ways of protecting it, but probably one of the more interesting ways that may be coming up in medicine is to use blockchain computing. We all know blockchain from Bitcoin. Simply what it does is patient would have a password and you would have a password. You then are entering into, you get the information, you entered in, you verify that it's there, you then have that is then encrypted and sent to other sources which have the same amount of data. Once it's there, it's verified, added to previous data, locked down and encrypted. And what this means is it's then it's unperturbable. It means that you can't change it, patients can't change it, but more importantly, an outside source such as a hacker can't change it. Now, the problem with this is, however, it requires huge areas of storage, and so this is a problem that's being developed, that's being worked on. Perhaps it's going to be, there'll be a central computer area, and then we will access in and out. But I think you should be aware that blockchain is something that is going to get out of just Bitcoin and very much going to become something important for medicine. So big data is everywhere. You're doing it, you're getting it. You may need to want to think of ways of protecting it, but it is something you're going to see. So thank you for your attention, and I hope you enjoyed it.